Hi everyone, today is Friday, August 12th, 2022. I am Man who finished lunch, and today we're going to do another exercise. So we are here in the Elixir syllabus, and we're going to do the exercise guessing game, which covers default arguments, guards, and multiple clause functions. So let's get right into it. So, default arguments. Functions may declare default values for one or more arguments. Let's consider this function. Define number takes n / 13 do. That's not my favorite number. When compiled, Elixir creates a function definition for number \0, no arguments, and number \1, one argument. If more than one argument has default values, the default values will be applied to the function from left to right to fill in for missing arguments. If the function has more than one clause, but the default argument should be defined in a function header, a function without a body before the function clause. If the function has more than one clause, the argument should be defined in a function header. Okay, yeah. So default arguments, kind of what you see here. I think one of the challenges with default arguments in my experience has been that I prefer to always have default arguments on the end of the list. Technically you can have them in the beginning, but because Elixir doesn't have named arguments, it becomes a little confusing sometimes when you provide, if something takes three arguments, and you define a default for the first argument. When you pass two, what is it going to call? I don't know. I've experienced some weirdness there, so I try to avoid that issue altogether and just put default arguments on the tail end of a function list. But so I've got that, and let's go back and we'll check out guards. So guards are used to prevent Elixir from invoking functions based on evaluation of the arguments by guard functions. Guard begins with the when keyword, followed by a Boolean expression. Guard functions are special functions which must be pure and not mutate any global state, and must return strict true or false values. A list of common guards can be found in the Elixir documentation and includes type checks, basic arithmetic comparisons, and strict Boolean operations. Let's take a look at the documentation. So these are some of the guards you can see here. And yeah, these are very popular when defining a function. So Elixir is not a strongly typed language, and guards are kind of one way you can influence the runtime to enforce some rules. So, for example, if you have a function that's coming in and you want to validate that the argument's being passed in or is an integer or a Boolean, you can kind of add a guard to that function definition. And you can even do other things like checking the length of a string, or looking for, binary is popular for string references and stuff. But yeah, guards are powerful. I find in my own work, I haven't used guards as aggressively as maybe I should. I think, and then this gets into, there are other ways you can kind of hint to the system that you want certain types to come in, which is a thing called typespec and tool called dialyzer. But those are external to the runtime. Guards are part of the runtime, and so if you can build a guard for something, you probably should, if you want your code to be very firm about what the expectations are. And finally, multiple clause functions, and this is a cool one. This is a very unique Elixir design. So Elixir facilitates open-close principle practices by allowing functions to have multiple clauses. So instead of sprawling and hard-coded control logic, pointed functions can be written to add remove behavior easily. Elixir offers multiple function clauses and guards to write And here they show define number n when n equals 7 do. And then they also have define number underscore n do. And so what they're doing here basically is we're defining, it's the same function, but you're just defining it multiple times. And so what'll happen is, as it explains, at runtime Elixir will test from top to bottom of the source file which function clause to invoke. Variables that are unused should be prefixed with an underscore. So you can build kind of like the same function, and based off of guards or pattern matching, which we haven't gotten into yet, the kind of function clause will be evaluated, and then whichever one, the first one that is like valid, that'll actually be executed. And I found that this can be a really nice way to kind of organize your thoughts and your behaviors. Anyway, it's pretty cool. It's definitely one of those things that's more unique to Elixir than other things that are just more common to every programming language. Alrighty, so with that said, we're going to go and work on the guessing game. You are creating a trivial online game where a friend can guess a secret number. You want to give some feedback, but not give away the answer with a guess. You need to devise a function to provide different responses depending on how the guess relates to the secret number. Condition: when the guess matches the secret number correct, when the guess is one or more less than the secret number so close, when the guess is greater than the secret number too high, when the guess is less than the secret number too low, when a guess isn't made, make a guess. Cool, this looks cool. Alright, so we're going to copy that, and we will download our example. So we'll go to users, Zorn, Exercism. Let's just copy it. I'm trying to be... Actually, it's probably in my history. If I just go... Now you're going to see all my other stuff, which is fine. Nothing too secret there. But alright, let me just copy this. CD, code. Alrighty, so once again, we'll open our library. Put that over there. We'll open our test file, and we'll open our readme. We'll open our readme, and then we want our test file. Actually, and then over there. Cool. Okay. So we only got one. Yeah, we only have one function here. All right, cool. So we went over our concepts, and we'll make this a little bigger. So make the response when the guess matches the secret number. Guessing game compare 5-5. Oh, so this is going to have the value that's supposed to match. Okay. So that is the secret number. That is the guess. Okay. Cool. Cool. So we'll start this out. We'll do when secret number equals guess. We'll respond with correct, and let's build a default. And this is the thing. So when you're defining your function, you can just put underscores, and that's totally valid legal code. I prefer to still write the name of the argument variable, just so it's clear like what would have been in there. All right, so we'll say make a guess. I don't think that's gonna work for everybody, but is that what? Make a guess, lowercase g. All right, so it's gonna yell at us. Variable does not secret number. Gotta spell it right. Alright, cool. Let us run all the tests on file. And we get some that pass, and we got a lot that don't. Alright, cool. So let's do number 2. Make the response when the guess is greater than the secret number. So we'll just kind of keep that going down. So when the guess is greater than the secret number, it should be too high. Let's do a couple more of these because I feel like we got our head around this. When the guess is less than, it'll be too low. And then there'll be one that's so close. Now, this will get into the issue of the ordering. So, like, if we were to do that here, this wouldn't really work well because it would always match too high or too low. So what we need to do is put it up here. And so what we want to find is when the difference of the secret number and the guess is 1. We want to say too close. Is there a way? I mean, so what we can do is we can do abs. I think we can do abs. Insert number, integer or float with the absolute value of number. So we'll do secret minus secret number minus guess, and if that equals 1, then we'll say too close. So close. So close. And that should, so secret number minus guess, that'll either be, if that equals out to be, -1 or +1, and then we do absolute, that should give us 1. 1 equals 1. That should match, and then so close should be called. Let's try running our tests. So we have 2 failures. What are, well, let me, then we need to say no guess. Yeah, so we haven't implemented that one yet. Make the response when there's no guess. So if they, so this is with the defaults. So they allow the passing of the atom no guess to represent nil type value. So what we'll do is we'll catch that at the beginning. So def compare, and we'll do secret. Secret number guess and do. When guess, yeah, you could we'll do it with the function header. So compare secret number guess, and this will default to no guess. And then what we'll do is we'll do it with a guard. So we'll say when guess equals no guess, it'll do make a guess. And then we can we'll get rid of this one because we basically want to say that like these should match all scenarios. But let's see here. Implementation not provided def. So did we did we do our thing with our header function? Oh, that's just an article. Right, let me see here. So our variable secret number is unused. Okay, so that way we just have to get rid of that. Implementation not provided by predefined compage. Oh, again, you gotta spell things right. All right, let's try test everything on file. Cool. So everything passes. So we've got our function header with our default. we're matching this with a guard. Later on, you can match this with a pattern match by putting no guess right here in the argument list. Cool. So this looks pretty good. Let's Exercism, submit, lib, guessing game. We'll check out our option. So this is our iteration 1. It looks like it passed. We'll take a quick peek at some of the solutions. Diff compare do. I'm wondering out loud here. Secret number. Secret number. Oh. We capture 2 things. Yeah, that seems weird to me. It seems weird to me because it's like they're not using secret numbers. So I would have assumed it would have yelled it about the non-use, but like I'm surprised that passes. Because I would think anything that gets called with these, that first version would be used. Interesting. Cool. So yeah, so they're gonna do this solution here. They provide the header with the default, and then they use pattern matching in the argument list to kind of solve for it, which is totally valid, and probably the preferred way to do it, but because we haven't really technically learned pattern matching yet, I'm kind of avoiding it in my own solution, but that's fine. All right. Yes, to compare, make a guess. If guess equals that's a little weird. I wouldn't expect that. I wouldn't expect. Well, one, they're doing pattern matching type stuff. Yeah, that's not a solution I would kind of look for. They're doing +1, -1, or yeah, if it's +1, when secret +1 equals guess, or secret number equals guess +1. Yeah, they're doing that. That's fine. It's a different type of math there. All right, cool. Def guard. This is hardcore. All right. So I'll talk about this a little bit. So we're used guards, and we wrote our guards kind of inline. But def guard and def guard P, in this case for a private guard declaration, is a way for you to write your own custom guards. And this can kind of come in handy when you want to kind of write your guards in the domain language that you're working with, which is really cool. In this case, you can see, is guess off by 1 makes a lot more sense. When you read this, like compare secret number when, is guess off by 1, then do, so close. Like that reads a lot better than doing like the math inside. They also use triple equals for 1, which is probably a nice safer thing than 2 equals, but I don't think it doesn't really matter with integer math. But yeah, def guards pretty cool. Definitely, if you write guards and you have an opportunity to describe the guard in your domain language, you should definitely check that out. Alrighty. So this is our stuff. Looks good. I'm gonna mark it as complete. I'll publish our stuff. And so we have learned 3 new concepts: default arguments, guards, and multiple clause functions. We've unlocked 2 new concepts: pattern matching and tuples. Pattern matching being probably one of the cooler Elixir concepts. Looking forward to getting into that. Then we've unlocked 2 new exercises, Leap and Kitchen Calculator. Cool. All right, so we'll get into those next time. For now, thanks a lot for watching. If you have any questions or feedback, definitely let me know. And I will see you next time. Bye-bye.